Okay, folks, we're going to move on and look at something called compound angle equations. Compound just meaning it's composed of a couple of different things. Let's just get right into an example then. Right, let's go for solve. Sine 2x minus 20 equals 0.5, and I'm looking for solutions that lie between 0 and 360. Okay, now the naming of it as a compound angle equation comes from this bit here. Okay, so what we've got is we've got a double angle, but we've also got this phase angle in here as well. Now, what we need to do then is we need to adjust our limits as appropriate. Now the limits for x is between 0 and 360, so what's happening to that limit then, or those limits, they're getting multiplied by 2 and then we take away 20. So the lower limit and the upper limit are both getting adjusted, we're multiplying them by 2 and then taking away 20. So what's happening to x? We're multiplying by 2 and then we're taking away 20. So 0 times 2 is 0, take away 20 is minus 20, so that's my lower limit. My upper limit then, 360 times 2 is 720, take away 20 is 740. Okay, so I'm looking for solutions then initially that lie between minus 20 and 740. Okay, now just keep your eye on with this stuff because it's easy to lose track, but no particularly difficult stuff at any given step. You just need to keep your eye on and keep focused and concentrating. Okay, so it's 2x minus 20 is equal to sine inverse 0.5. So at this point, I'm going to put up the cast diagram. Okay, it's a degrees question, so let's record that. 0, 90, 180, 270, and 360. I'm in the all quadrant and the sine quadrant. Okay, so 2x minus 20 is equal to sine inverse 0.5. Okay, that's one of my exact values then. And for sine, when's that equal to 0.5? 1/2, that is 30 degrees. That is my all quadrant solution. I'm also in the sine quadrant. The sine quadrant is telling me to take away from 180 by 30 degrees, and that is 150 degrees. Okay. Now remember that the sine curve repeats after the sine curve repeats after 360 degrees. So we need to start exploring for more solutions, because we need to exhaust between minus 20 and 740. Okay, so if I add 360 onto 30, that's 390, that is still within range. If I add 360 onto 150, that's 510, still within range. Okay, if I add 360 onto 390 then, that's going to be 750. That's out with range. I'm going to cross that one out. Okay. Next move is I'm going to bring the minus 20 over and add that 20 to all my solutions. So that will be 2x equals 50, 170, 410, 530. My next move is to divide everything by 2. So it's going to give me 25, 85, 205, 265 final answer. Okay, let's try an example 2. Okay, example 2, I've got 3 cos 2x plus pi over 4 is equal to 1. And I'm going to solve this correct to 1 decimal place. That's probably insinuating this is going to involve using a calculator. And my limits are between 0 and pi. Okay, now the first thing that I would do there is, I think the insinuation, if it's to 1 decimal place, we're in radians, change your calculator to radians mode. Okay, so the default for the calculator is often degrees mode, deg, but you want to change that on to radians mode. Okay, so bring the 3 down, divide. That's 1 divided by 3. What I should also do at this point is to adjust my limits. So my limits for x are between 0 and pi. So what I'm going to do then is I'm going to multiply those limits by 2 and then add pi over 4. I'm going to multiply the limits by 2 and add pi over 4. Okay, so the lower limit multiplied by 2 is still get 0, add pi over 4, and the lower limit is pi over 4. Okay, upper limit, I'm going to multiply it by 2, which will give me 2 pi, and then add pi over 4, so 2 pi plus pi over 4. Let's start thinking about pizzas. 2 pizzas plus a quarter of a pizza. Well, 2 pizzas is 8 quarters, plus another 1 quarter is going to give you 9 quarters of the pizza. Best done by visualization. Okay, next move. 2x plus pi over 4 is equal to cos inverse 1 over 3, and let's get the cast diagram up. Okay, so cosine is going to be an all in cos. Okay, so in radians mode with the calculator just now, try cos inverse 1 over 3. Okay, into 1 decimal place, that should give you 1.2 radians. I'm also in the cosine quadrant, remember? So for the cosine quadrant, I'm going to subtract my solution from 2 pi, so it's going to be 6.28, take away 1.2, and that will give you, to 1 decimal place, 5.1 radians. Okay, now let's just have a feel for what's the kind of decimal fraction equivalence for these. Okay, so pi over 4, 3.14 divided by 4, so that's about 0.785 from our lower limit. And for the upper limit, it's going to be 9 times 3.14 divided by 4, which is about 7.065. Now what you can see then is both of these are within range, 1.2 and 5.1. However, if I was to add 6.28 onto 1.2, that would take me out with range, so that wouldn't be a solution. So let's write that one down and cross it out anyway, so that'll be 7.365. That's out with my limits. Cross it out, and you can see there's quite a few things to be thinking about here, so you just need to keep your eye in, keep concentrating. Okay, so my next move then is to take the pi over 4 across and take it away from the 1.2 and take it away from the 5.1. Okay, so it's going to be 1.2 minus pi over 4 in the calculator, and 5.1 minus pi over 4 in the calculator, and that'll give you, okay, so that will give us about 0.4 here, and about 4.3 here. Okay, my next move then is to divide both these results by 2, and that will be 0.2 and to 1 decimal place, 2.2 final answer. Okay, let's try an example 3. Okay, example 3, we're going to solve a 4 tan (3x plus 45) is equal to minus 2.5, and we're looking for solutions that lie between 0 and 180. Okay, first move, let's adjust the limits. Solutions for x lie between 0 and 180, that's what we're looking for. We're going to multiply them by 3 and add 45. So 0 times 3 is 0, plus 45 is 45, there's my lower limit. Okay, upper limit, 180 times 3 is 540, plus the 45 is 585. Okay, let's now bring that 4 down and divide, and that's going to be tan 3x plus 45 is equal to minus 2.5 over 4. Okay, now what I'm going to immediately do then is just change that into a decimal fraction, and that will give me minus 0.625. I'm then going to change that to be a positive result, as per usual for a trig equation. If it's equal to a negative result, let's get the cast diagram up. Okay, it's degrees, so 0, 90, 180, 270 and 360. Okay, but in tan, so for tan we would normally look in all in tan, but it's negative, we've changed it to positive, we're going to look in sine and cos. Okay, so 3x plus 45 is equal to tan inverse 0.625. Okay, that's a calculator question then. So tan inverse 0.625. Make sure you're in degrees mode then. That's just going to give us about bang on 32 degrees. Okay, now I'm promptly going to record the fact that I'm not in the all quadrant, therefore that cannot be a solution. But it's useful to me to get the sine quadrant solution. 180 take away 32, which is 148, and for the cosine quadrant that's 360 take away 32, and that is 328 degrees. Okay, now remember that tan repeats after 180 degrees, and I need to exhaust all solutions within this range, between 45 and 585. Okay, now if I add on 180 onto 148, that's going to give me 328. Okay, it's still within range. Right, but I've already got that solution, so I don't need to write it twice. If I then add on 180 onto 328, I'm going to get 508, still within range. If I then add 180 onto that, that's going to give me 688, and I'm beyond the range that I'm looking at. Okay, so that's my solutions for 3x plus 45. Okay, so next move, I'm going to get the plus 45, I'm going to take it away from each of these. And 45 off of 148 is 103. 45 off of 328, well, that's going to give me 283, and then 45 off of 508, that's going to give me 463. Okay, final move, and remember we do have a calculator, is to divide by 3 to one decimal place. 34.3, 94.3, 154.3 degrees, final answer. Okay, now we're going to leave the most awkward to last. Not any more difficult, I would argue, just a wee bit awkward, quite multi-layered. Keep concentrating. Okay, 2 sine. I've got 2 sine 2x minus pi over 3 equals 1, and I'm looking for solutions that lie between 0 and 2 pi. Okay, bring the 2 down and divide, and I've got sine 2x minus pi over 3 is equal to 1 over 2. Okay, let's now adjust the limits. So my limits for x are between 0 and 2 pi. So what I'm going to do then is get the limits, multiply them to 2 by 2 and take away pi over 3. Okay, so the lower limit multiplied by 2 you get 0, take away pi over 3 minus pi over 3. Upper limit multiplied by 2 you get 4 pi. Take pi over 3 away, well look at 4 pi, take away pi over 3, so 4 full pizzas, that's 12 thirds, 12 thirds take away 1 third is 11 thirds, 11 pi over 3. Okay, 2x minus pi over 3, I can tell already that this is definitely a non-calculator question. Sine inverse 1/2, and I'm going to put up the cast diagram. Okay, so we're in the all and the sine quadrant. Okay, so 2x minus pi over 3, So sine, when's it equal to 1/2? So that's 30 degrees. However, we're thinking in degrees probably, but we need to write in radians. Now, what you could do at the side there is write your 30 degrees. Remember that pi radians is your base, that's 180. 30 degrees is 1/6 of that, so that's pi over 6. Okay, that's my all quadrant solution. Now, what about my solution in the sine quadrant? Well, for the sine quadrant, we're moving backwards from pi, so we're taking away from pi. So you've got a pizza, you take away, you eat 1/6 of that pizza. That's 5/6 of the pizza, 5 pi over 6. Okay, now see this point, let's just be dead careful. Make sure we make this as straightforward as possible. Right, there's my limits. Right, between minus pi over 3 and 11 pi over 3. Now, I need to work out if these two are within those limits and if I've got any more solutions that would lie within these limits. Now, what's the wee issue we've got here? Well, we don't seem to have like for like here. These are written over 3 and these are written over 6. So let's get a bit of consistency here. This isn't that difficult. Let's write these over 6. So minus pi over 3 would be minus 2 pi over 6. And 11 pi over 3, well, just top and bottom by 2 then, would be 22 pi over 6. And then it's quite easy for me to say then that I'm within range for both of them. Okay, now, next thing, what am I thinking? Well, I'm thinking that for sine repeats itself after 360 degrees. Just going to read this again, give myself a wee bit of room. 2x minus pi over 3 equals pi over 6 and 5 pi over 6. Okay, so the sine curve repeats after 360 degrees. Now what that's equivalent to then is 2 pi radians. Okay, now if you think about 2 pizzas and you split those pizzas into sixths, what you end up getting at that point is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 6. So I'm going to add on 2 pi, I'm going to keep it as 6, so I'm going to be adding on 12, 6. So 1 6 plus 12 6 is 13 sixths. Still within range. 5 pi over 6 plus 12 6, 17 pi over 6. Still within range. 13 pi over 6 plus 12 pi over 6, 25 pi over 6. Okay, now that is out with the upper limit range. Okay, my next move then is to get that minus pi over 3, bring it across and add that to each of these solutions. Okay, so let's just take our time, create plenty of space in your jaw to do it, try and make it very clear. Okay, so it's going to be pi over 6, so I'm bringing that over, adding that pi over 3 on, and then it will be, I think that's that one down, 5 pi over 6 plus pi over 3, that's that one done, 13 pi over 6 plus pi over 3, that is that one done, and then finally 17 pi over 6 plus pi over 3, and that's that one done. Now, in order to add these fractions, let's get a common denominator, so multiplying top and bottom by 2, so that I bring them up to 6. There's a lot of detail as you can see here, but I would argue that each separate step is not that difficult, it's just about putting it all together and executing. So, pi over 6 plus 2 pi over 6, 3 pi over 6. 5 pi over 6 plus 2 pi over 6, 7 pi over 6. 13 pi over 6 plus 2 pi over 6, 15 pi over 6. And then finally 17 pi over 6 plus 2 pi over 6, 19 pi over 6. Okay, almost there. Final move, I need to divide through by 2. Now if you divide through by 2, what you basically do then is you double the denominators. So that will give me 3 pi over 12, 7 pi over 12, 15 pi over 12, and 19 pi over 12. Now, does that make sense? Well, it does make sense, because if you think about half, and if you half it, you just multiply the denominators, you get 1/4. If you think about a third and you half it, you just multiply the denominators and you get 1/6. So I'm dividing each of these by 2, leaves me with a denominator each time of 12. Now, almost there, but have I done everything? Well, the only thing that I would say is just keep an eye out right at the end. Is there anything that can be simplified? And this one can be 3 pi over 12. That comes right down to pi over 4. The rest of them can be simple. This one can as well. Top and bottom by 3 will bring me down to 5 pi over 4, dead easy to miss. That one cannot be simplified. Final answer.